Hi friends and my dear students. Today we are going to see in 12th Physics 8.4 nuclei, the nucleus of an atom. Before going to see the topic, one famous 5 mark question that was asked and very repeatedly in the annual examination. Limitation of Bohr atom model. There are 4 points. First point, Bohr atom model is Bohr atom model is valid only for hydrogen atom or hydrogen-like atoms. It will not explain by means of complex atoms according to Bohr's theory. That's why the first limitation is called hydrogen atom. Hydrogen atom model itself, the Bohr explained. Complex atom model cannot be explained by Bohr's theory. The second one, when you think about the spectral line of hydrogen atom, there may be a more number of fine lines within the same line, and it may called as a fine structure. It may called as a fine structure of the line. That means it seems to be like one line, one spectral line, but instead of that, there may be more than 3 or 4 faint lines are available in the same line, and it may called as fine structure. This was not explained by the Bohr's theory. And third one, Bohr atom model fails to explain the intensity of the hydrogen spectral lines or the various spectral lines. If you consider 3 or 4 like this, then the intensity may be varied. The reason for the variation of this intensity of the spectral lines, various lines, cannot be explained by the Bohr. That's why these are all limitations. That's why we are neglecting Bohr's atom model. And the last one, when you think about an atom, then the distribution of the electron cannot be completely explained by the Bohr atom model. This is the fourth important limitation. These 4 things are very important. It may ask in the 3 mark questions or 5 mark questions. Limitation of Bohr atom model. I hope you may understand clearly. Then now we are going to start our topic, a nucleus or nuclei. When you think about nucleus of an atom, or generally you consider an atom, electron are revolving in the orbital. Okay. In center there may be a nucleus. If you consider one atom, there is one nucleus. Inside the nucleus there may be proton positively charged and electron is negatively charged. Here the number of proton equal to the number of electron. So this one is positive and this one is negative. This one is positive and this one is negative. In general, if you say X is an atom, then Z is the number of proton or number of electron. Then A is called, what is meant by A? When you consider the nucleus, there may be not only proton but also neutron also accompanied with the proton. Neutron or be here in the nucleus itself. So, the nucleus contains 2 particles. One is proton and another is neutron. This is positively charged and the charge of the neutron is equal to 0. Charge of the neutron is equal to 0. Now, what is the, how can we represent the atomic structure of an atom, or how can you express any, suppose if you consider 1H1, what is my 1H1, what is the value of 1, what is the value of 1? That's why, suppose I want to explain atom name is X. Z is considered to be, it is nothing but N plus P. N plus P means number of neutrons plus number of protons. A means number of neutrons plus number of protons. This is called atomic mass number. Atomic mass number. Atomic mass number is called A. It is nothing but N plus P, number of neutron plus number of proton. Number of neutron plus number of proton. This is called atomic mass number. Whereas Z represents, Z is nothing but number of protons, number of protons. Okay, are you clear? Number of protons are equivalent to number of electrons, I already told. So that Z means number of proton or number of electrons. Both are equal. Now, this is fundamental things that we have to understand clearly about the atom. Inside the nucleus, there are protons, there are neutrons. Here, the charge of the neutron is equal to 0 and this one is called positive. So, the total nucleus are considered to be positive and it may be called as Ze. Ze plus Z into E. Why we are called as Ze? Z is nothing but, if you consider the proton have positive charges, the positive charges are, the proton positive charges are represented plus E. So that the total amount of nucleus positive charges called number of protons called Z. That's why Ze. Here, when you think about or you want to explain what is meant by atomic number, atomic mass number. Atomic mass number is nothing but the total number of neutron plus total number of proton is called atomic mass number and it was represented as A. Whereas atomic number is denoted by the letter Z and it is nothing but number of protons or number of electrons. Number of protons or number of electrons. This is a fundamental definition that we have to understand clearly. Now, as per in general, what is the value of proton or what is the value of neutron, or sir, is there any other method to call this particle inside the nucleus? The particle available inside the nucleus may be called as nucleon. That is called, it may be called as also nucleon. That is very, very important concept because it is constituted by the nucleus and hence it may be called as nucleon. Nucleon is nothing but proton and neutron. When we think about nucleus, the particles are here inside the nucleus. That's why it may be called as nucleon. Nucleon is nothing but the particle constituted by the nucleus. That's all. So it is nothing but proton and neutron. Now, we want to give the specific value of the. Now we have to represent. Sir, is any other method in general other than the textbook? Yes, you can write X, A here or Z here. Suppose, for example, 1H1 like this, or you have to write 1H1 like this. This is called Z, this is called A. Here, the number of protons is equal to 1, number of neutrons equal to 0. Here, the number of proton or the number of electron. This is also the same, or this way or that way, whatever it may be. But in your textbook, it may be followed like this method. So, in general, this both are correct. Both are correct. Now, here, suppose when you say 1H2, 1H2 means proton numbers is equal to 1. Here already told A is nothing but 1 plus 1, that is 1 is called proton and another one is called neutron, and number of electron is nothing but 1. This is called atomic mass number. A equal to 2. Atomic mass number. It is not atomic mass number. This is called atomic number. Atomic number, it is nothing but either number of electrons or the number of protons. Here, that is the basic representation to clearly understand the concept of the nucleus or atom. This is very, very important basic. Then, we want to give the value of mass of proton. What is the mass of proton? If you want to give the mass of proton in kilogram, then we can give the value of mass of proton as per in your textbook. Mass of proton like this, MP. Mass of proton, that is nothing but 1.6726 into 10 power minus 27 kilogram. This is called mass of proton. And mass of neutron, that is equal to 1 point slightly higher than the mass of proton, 6749, slightly higher than the mass of the neutron is slightly higher than the mass of the proton into 10 power minus 27 kilogram. Now, we want to find out the mass of electron. This is equal to 1836 times of the mass of electron into multiplied mass of electron equal to mass of proton. 1 mass of proton. That is, if you want to find out the mass of electron, then you have to write the value of mass of proton divided by mass of proton is nothing but 1.6726 into 10 power minus 27 kg divided by 1836. This is called mass of electron. And so that we get 9.1 into 10 power minus 31 kilogram. This is the mass of electron. These are all the fundamental concepts that you must know to answer for all physics sums or NEET or whatever it may be in 1 mark questions. Likewise, you must be clear. Okay. Next, Next, we are going to explain 8.41. We already explained the topic under the heading of 8.41. Now we are going to see 8.4, 8.42. Very important for 3 marks. What is meant by isotope? Isotope. What is meant by isotope? Isotope, isobar, isotones. These are three important basic 3 mark questions that you must know clearly. What is meant by isotope? When you say isotope, for example, let us assume X and Y. This is an atom name. Here Z into A. Here Z into A. Suppose I can give an example. If both X and Y, atom of X and Y have the same value of Z, then it is said to be isotope. For example, 1H1, comma 1H2. Here mass number is differed, but it is a constant. That is 1 proton and 1 proton. There is no change in the proton. Likewise, you have to put 1H3. This is also constant. Constant means for isotopes of hydrogen, there are 3 isotopes. For element to element, the number of isotopes may be varied. When we consider about hydrogen atom, there will be only 3 isotopes. 1H1, that is called hydrogen. Second one, 1H2, that is called deuterium. 1H3, that is called deuterium. Here, what is the basic difference between these 3? All Z is equal to constant. All Z, there is no change in the Z. There is no change in the proton numbers, but here number of neutron equal to 0. Here number of neutron is equal to 1 plus 1. Here number of neutron equal to 2. Here these are all called neutron number. This is called proton or electron. In nucleus it may called as proton. Here it is called as electron. This is called isotope. Same atomic number, but different mass number. Same atomic number, comma, but different mass number. 1H3. Different mass number. Mass number is differed, but atomic number is same. And these are called isotope. These are called isotope an element of hydrogen atom. Sorry, is it a constant? If you consider any element, there may be only 3 isotope? No, not like that. When you consider an element to element, it may be varies of number of isotopes or number of isotopes may be differed. For carbon, there may be 4. For nitrogen, there may be 2. Likewise, when you call uranium, then you can say 3 or 4. Likewise, it may be varied, depends upon the element name. This is called isotope. Isotope is nothing but same atomic number but different mass number is said to be isotope. I hope you may understand clearly. Isotope. Okay. Then what is meant by isobar? So as per the here before going to isobar, here in atomic the properties of physical physical property and chemical property, it depends on only on electron number of electrons, number of electrons, not depend on the atomic mass number, or it depends on Z only, Z number of electrons only. That's why in periodic table, even the hydrogen has 3 isotopes, then you have to give only one place for hydrogen atom in the periodic table, and there is no change in the physical property and the chemical property, because electron not changing in the hydrogen atom, only there may be changing in the neutron itself. So the formation of isotope is nothing but when you adding of neutrons or removal of neutrons, it produces the isotope. That is the fundamental phenomena that was not available in your textbook. You have to clear. Suppose you consider one H1, that means one proton, one electron. If you adding one neutron here, this is called proton, this is called electron. Adding one neutron here, then it may call as one H2. That is adding of neutron, or you have to remove one neutron, then you get one H1. So adding of neutron or removal of neutron produces isotopes. This is a fundamental phenomena that was explained, but this definition is not available in your textbook, but you must be clear. This is the basic concept to explain the isotope. Then we are shifting to the isobar. What is meant by isobar? Isobar is nothing but isobar is nothing but same atomic mass number, but same atomic mass number, isotopes for the term. Next we are going to see isobar. Isobar is nothing but same atomic mass number. Here A is constant. Here Z may be varied. Here Z plus 1, Z plus 2, Z plus 3 of any element, X, Y, Z or K, any element, whatever it may be. Here atomic mass number are constant, but there may be variation in the atomic number. Mass number is constant, but atomic number is differed. Then you can say it is called isobar. For example, when you say sulfur, 1640 sulfur, or chlorine. When you say chlorine, then 1740, or arsenic 1840. That is, here Z is varied, but A is constant. 40 is atomic mass number is constant. Arsenic, and then we can say potassium 1940, and then last one, calcium, Ca, this is 40, here 20. In this example, here Z 16, 17, 18, 19, 20, but A is remaining constant. This is a very good example for isobar. Same atomic mass number, but a different atomic number is called isobar. This is a very good example. This is a very good example for isobar. Isobar. Here, number of electrons are before, there may be physical property and chemical property are deferred, not like isotope, because there is no change in the electron numbers. That's why physical chemistry property are constant. Here it varies. That's why physical property of isobar or chemical property of isobar may be varied. That's a very important concept to understand clearly. Now, at last we have to isotone. What is meant by isotone? Isotone. Another 3 mark question. Isotone is nothing but, if you consider any atom X, if X of n means the number of neutron in X is equal to number of neutron in Y. That is, an atom X has neutron is equal to the neutron in the atom of Y. There is no change in the neutron, then it may call as isotone. This is a very, very important definition. Here, for example, when you say B, boron, 6C12. When you say carbon, 7 or 6, here 5. Boron means 5. When we say carbon 6, atomic number 6. When you say boron, atomic number is 5. Here 13. Here both are varied. Atomic number also varied, atomic mass number also varied. Suppose I want to get N, so that A minus Z is, this is the basic formula to calculate how many neutrons in an atom. What is the neutron number? It is atomic mass called A. Atomic called A is nothing but 12. Z is nothing but 5. Then A minus Z, 12 minus 5, that is equal to 7. Okay, are you clear? In the same way, here when you think about carbon, N, that is equal A. A means here A, 13 minus Z. Z means 6, then that is equal to 7. Therefore, neutron number equal to N equal to 7. Here N equal to 7. So, if the nucleon number is same for more elements, then these atoms are said to be called isotone. This is a very good example for isotone. Boron as well as carbon. Boron. When you say atomic number is called 5, it may called as boron. Depend on the electron number or proton number, we give the name of the element boron. And proton plus neutron. Here 13. So this is called 5. Remaining 12. Remaining, this must be 7. I hope you may understand. Likewise, if you explain C, 6 proton plus neutron, 7 neutron, then that's called 13. That's why when neutron is constant, these elements are said to be isotone. This is very, very important to understand clearly, and it is very easy to understand, but there may be a lot of 3-mark question and 1-mark question may be asked in your examination. Thank you, my friends.